and also verify that the other channel and it is. In this particular instance, these two speaker fuses are 4 amp and they're quickies. What we're going to do now is unhook everything, and we're going to check little things that matter. For example, one of the things you want to check is the offset and the bias, and the offset is R8. That's this little fellow right here. And then R12 is your bias. R8, what you want to do is you want to take the output of the amplifier, and what you want to do is take the meters, put the meter on volts, DC volts, clip that onto ground. That's ground right there. That is minus 30, and that is plus 30. It varies a little bit with line voltage. It could be 29. It could conceivably be a little more or a little less. Now this particular amplifier is sitting here right here, and so therefore we're going to go that. And as you can see, as I turn this, see, that's going 3/4 of a volt, 5/10 of a volt. You want that to be as close as possible to 0. Now, not every amplifier has an offset control, but this one does. This one's not completely automatic. 047. We're going to go for the lowest number. See, now it went up to 2.3 again. Because you go from like plus 0.5, sometimes even higher, to minus 0.5 as you travel through the range. And what you want to do is you want to get it so that it's the lowest it can be. That's about as low as it's going to go. And if I try to go over the little more to the next direction, that's about a little lower. And I'll try it a little more. That's a little higher. Let me go the other direction. All right, that's a good number. Less than 1/10 of a volt is preferred, and that is the voltage, the DC voltage that your speaker sees when there is no signal. And by the way, it varies with temperature. And it can change over a period of time as the transistors warm up. The next thing you want to look at is your bias. And to do that, what you'll need to do is you'll need to clip across the resistor. And I want you to know this is not, neither one of these is a ground potential. Now that particular one is sitting at 0.16, and you'll need to use a calculator with this. The value of the resistor, in case these, on some of these units there's a bare wire that they use for a resistor. On other units it's an actual resistor itself. We want you to know that that is approximately 0.47 ohms, in case that ever blows up. And we measured a voltage across there. It's going to be about the same in both cases, of 0.16. And you'll find that if you use a calculator, and I'll use the phone as a calculator here for a second, but the value is going to be specific. So what you want to do is take the voltage reading you had, which was, in this particular instance, 016 and divide it by 0.016 and divide it by 0.47, and that should give you your current, which is 30 milliamperes. And that's about right for this type of amplifier. It's in the ballpark. Between 25 to 35 milliamperes is right. So it's 03 amplifier. So what you're shooting for is approximately the same on the other channel. And we'll just randomly pick this. And it might be positive or negative depending on which way you've got your leads on. If you do have to adjust the bias, adjust that, but very carefully. Now see, this one reads 028. So 028, if you want to double check, is 028 and divided by 0.47 is 60 milliamperes. This one is reading high, and this one is correct. So you want to make it lower than that. And so to do that, what you want to do is you want to adjust R12. You want to put your probe right here on the other side of the resistor, and then you want to adjust it very slowly and carefully. Now that you can see is going up. You don't want to exceed 100 MA in any case. Okay, that's 020. And to double check our calculation again, what we're going to do is it's 020 and divided by 0.47, and that gives us 40 milliamperes. So what we want to do is we're going to go a little lower. You want approximately 30 milliamperes. And that happens when you change any parts in there, like any of the driver transistors or the output stage. Okay, it's 016. And to double check, it's going to be about the same in both resistors. Give or take a couple of, if you get two widely different readings, there's a problem with the driver. Like for example, if this one gives you a current and this one's twice as much current, there's a problem with the driver or the outputs. And so that's 016 divided by 0.47, 30 milliamperes. So now the bias is set in both of these units, and the offset is set on both of these units. And at this point in time, you can disconnect all your goodies, and don't forget the fuse that properly belongs in the AC receptacle coming in is 3 amps slow blow. And the reason you want to make it a slow blow rather than a fast is, you know, occasionally there are surges and things like that when you first turn it on, and it's a problem if you blow a fuse in the middle of a gig and you have nothing to work with. The 3 amp slow blow will allow a momentary surge, but if any part, say like a transistor, burns out, the fuse will blow within 5 seconds or so. So that will take care of the matter as far as safety is concerned. And that concludes this portion of the repair on this particular amplifier.